So I work at Craigslist. That's still sinking in. I just started in October. It's a pretty awesome place to work. I love being able to come to a conference like this and tell you that I work for a company that puts people before money. It's an amazing place, lots of really cool people doing lots of cool stuff. There's tons of challenges, tons of technical challenges, and it's a small company of only 50 people total, so it feels more like a family than a company. Please check out the positions we have open. Even if we don't have something that matches your skill set, try to find the closest thing. We write positions, but we hire good people. I strongly encourage you to consider it. The only downside is it's in the Bay Area. You know, Star must be willing to relocate to San Francisco. That was a huge negative for me, but I can tell you it was totally worth it in the long run. So today I want to talk to you a little bit about time series databases. How many people are using time series databases in their infrastructure right now? And how many people understand how they work? Yeah, cool. So some of this is going to be repetitive to those people, redundant even, but hopefully there's some stuff you can learn here for everyone. And if you're not using time series databases, hopefully you start using them after this talk. But first we need to know why I'm arriving here at this destination, why I'm taking you down this road. Things started like this in the 90s. Has anyone seen this page before? At a Perl conference, it's likely almost everyone in the room has seen one of these. This is MRTG, and I don't know if you guys had that experience of the first deployment of MRTG in a company, but it was amazing. All of a sudden, you had graphs, you could see stuff, everyone was excited. Prior to this, it was Big Brother, little like submarine alerts going off with little blinking red lights, but now we could actually see why those lights were blinking red. It was so successful that Tobias actually broke off the graph storage and generation engine into RRD tool because other people wanted to do other things with it. And this is where I spent most of my time writing cool stuff in the early 2000s, was in RRD tool itself. And it was great, except for I had to know what I was going to store, when I was going to store it, how I was going to store it, how we was going to graph it before I actually created the data source. And that. How many people know reverse Polish notation? Put your hand down if you learned it outside of RRD tool. Yeah, so most of the people learned it because of RRD tool. So where are we now with time series databases? There's a few open source solutions that are available, and you know, everyone has these cool like software as a service. There's now MAAS, which is monitoring as a service. So there's even hosted solutions that are available. You install their agent, it sends your data into their systems. There's some benefits to that. You don't have to worry about monitoring your monitoring infrastructure because they monitor their monitoring infrastructure for you. But you do lose a little bit of control over the data that you're sending. And if you're paranoid, like you happen to work in the security industry, you start to think about what people could glean from the monitoring data, and that might freak you out a little bit. So what do I use? I use Graphite. I'm good friends with Jason Dixon, who's one of the project maintainers, and if I don't use it, he'll hurt me. Another option is InfluxDB. This is a newcomer to the scene. It's really easy to send metrics. There's this concept called Metrics 2.0, which is it came out of Graphite's, and we'll look at this in a little bit, but the dotted path notation wasn't enough context for the monitoring metrics, so key values needed to be added to the metrics as well. And so Metrics 2.0 supports a key value system for storing metrics, and Influx database has that built in, so it supports Metrics 2.0 right out of the box. And the interface is like SQL. So if you know SQL, you can get metrics out, you can combine metrics, you can aggregate them, which sounds really great. The downside is that InfluxDB doesn't read scale very well. It write scales better than Graphite, so if you want to send a ton of data to it, you can do that. But if you want to get that data back out, then it's not quite as good at that. You will not be able to do one-to-one write-to-read with InfluxDB. At the time that I was involved in the evaluation of this, it is getting better. They are learning and they are making improvements, but it's still not as good read performance as Graphite is. Then there's OpenTSDB. OpenTSDB, again, supports metrics 2.0. It's easy to get metrics in. It has an H-based backend, so you don't need to roll up any metrics. One of the things with Graphite, which we'll talk about, is metrics need to aggregate and they need to roll up at certain boundaries. With OpenTSDB, you can just forfeit that all because everything's in Hadoop anyways. It's big data. Again, the downside is that the read scalability is compromised for that large storage option. So if you need to do lots of reads against your time series database, this may not be the greatest solution. And also, some people would put an H-based backend in the con. It's up to you. It's your organization. Your mileage may vary, and that's okay. Use what makes sense. Those are the options. I'm going to talk to you today about Graphite because that's what I have the most experience with, and I have yet to come across an instance where it hasn't solved my problems. I use it because it's open source. There's a ton of projects in the that interface with Graphite. You probably don't need to write something because something's already out there. It's scalable, so we can start with a Docker instance, we can start with a VMware image of Graphite, and then we can scale that instance of Graphite up into something that can handle millions and millions of metrics per second. It's easy to use for me as an administrator, for you as a developer, for a product owner who wants to find out what's going on in the system. It's very easy for them to use as well. And this is the most important thing. It's composable. The guys who started Graphite kind of decided to apply the Unix philosophy to monitoring. It's do one thing well and allow interoperability with other tools. So part of the reason there's such a large ecosystem of tools in the Graphite world is because they came at it from, we're going to provide an API, and that API is going to be consistent. And every point in the system is going to be interchangeable. So if you don't like the way one piece of the infrastructure works, you can pull it out so long as you maintain the API in and the data points out. And because of that, it's just, you can do anything with it. You're not locked in like you are with something like Cacti, where you have a configuration, it's a black box. With Graphite, your data is free to flow, however you'd like to do it. If you're developing an open source project, you need to think about how can I exchange my data freely with other people, because that's really what's giving Graphite its power. And of course, it's fun. I love looking at graphs. I love mutating graphs and finding trends and being able to actually have data to come to someone and say, here's why your process failed. Here's why this was slow. Here's why this is succeeding. Let's take a look at it. It's a lot of fun. So what is time series data? Time series is a measurement at fixed intervals. You can't have two measurements for the same data point. And in Graphite specifically, if you have a bucket of time and you have two readings, the last one that gets to the storage engine is the one that wins. It may not be the most recent. It could be one that arrives out of order. But the last one to that bucket wins. It overwrites the buckets. And again, the important thing to think about here is these are things that are measured at consistent intervals, right? So I'm taking this counter at this every minute, every 10 seconds. If there's going to be a long period of time where there's not going to be an event, that's not really the place for a time series database, because that reading, unless it's important, right? So the only exception to this that I can think of offhand is like error rate on an interface, on like a NIC, where you expect that counter to remain at 0, except when it goes up, and then you really want to know about it. But for the most part, if you have like an alert in Nagios, that is not time series data. Maybe the number of alerts per day is time series data. So you have to think about what your data actually is. Don't just stuff everything into Graphite, but stuff everything into Graphite. So if you've worked with RRD tool, you may be familiar with the concept of gauges and counters. Graphite doesn't care. It's up to you to know what you're storing and how to retrieve it. So the storage and the retrieval are two separate parts. So it doesn't matter if it's a gauge or a counter, you give it a value, it stores it. That's it. It's simple. Gauges and counters, don't use gauges. Gauges will hide problems. So if you're looking at interface bits per second as a gauge, and you measure it, and then in between the minute that you measure it, you have a huge spike, and then it drops back down again, you just lost that data. Whereas with a counter, you may not be able to find the exact microsecond that that particular spike occurred, but you will be able to see that there is a spike in that minute interval. And then if you have problems with microbursts and stuff like that, you can adjust your time series retention so that you can poll more frequently. So favor counters over gauges. How does graphite work? I already kind of alluded to this, but we have a dot-separated namespace. Here you can see this is what a metric name looks like. You might have, what I've adopted more recently is using the collector name as the first piece, followed by the data center, followed by the hoster role, or the role or build of the server, followed by the host name, the type of metric, and then the metric identifier. The metrics are all created automatically on the first time that they're stored. So you don't need to pre-declare these. The second that you write them to the Graphite instance, they're created if they don't exist already. All the storage is pre-allocated. So once you create the metric, there's no need for the disk to really go through a lot of intensive I/O to add additional things on. The storage is completely allocated. There's multiple storage engines. You can try Series or Cynate. They're nice. They have a little bit of additional, sharding and replication features built in. But for most purposes, the Whisper flat file data store is more than sufficient. And actually, you can get a lot of scale out of Whisper just by sharding the data using relays. For queries, you can ask for a metric by name. You can ask for all the metrics of a particular thing using stars. You can then combine, mutate, or select, fine-tune your pickings using functions. The nice thing about Graphite, and the most powerful thing, and one of the reasons why I think if you're doing monitoring write, you have a higher read than write load on your monitoring system, is because you can return this data as graphs, so you can look at it as a human, but I don't really want to watch graphs all day. I want to write code, and so I can use the JSON output to actually use that data to make intelligent decisions. I let computers monitor computers because they're better at it than I am. So there's a few components. Go ahead.
So you mentioned that they're basically using the last wins collision rule. Is there support for any other kind of collision rules like there is with our detailed?
Okay, so the question is that the last value wins in a collision with a metric name. Is there a way to configure that so there's a different set of rules for that? And the answer is no, with an asterisk. It depends. You can get very clever. We'll talk about this. Maybe, I think it's in here, but there's ways that you can relay metrics through to aggregators. So you could potentially say, okay, for this metric, I want to, if it has this name, I want to I want to sum these, I want to average them, I want the median, I'd like the standard deviation, the variance. You can do all of those types of things in an aggregator. So you can provide some wrappers around that, but by default, when it gets to the back end, the storage back end, if you say there's 1 point per minute, and you have a metric coming in, a finalized metric that's through your aggregators, that's every 10 seconds for some reason, because there's a mismatch between the storage engine and the generation, the last 10-second update to arrive at the store, not the last one sequentially by epoch, but the last one to arrive at the store will win. And if you're doing replication and the metrics arrive out of order and they're different values, you can end up with two nodes in the same cluster that have two different values because the last value was different because this one received it out of order, this one received it in order. So it's not super precise in that regard. You can take some precautions using relays and aggregators to prevent that. Yeah. So there's a few components of Graphite. Carbon is for routing and storing metrics. There's a few daemons in there. There's a carbon cache, carbon relay, and carbon aggregator daemon. I think I'm going to get into those, but Carbon is the backend that allows you that the Graphite web front end actually queries to get the metrics and you send the metrics to. And it's called carbon cache because it uses in-memory caching under the assumption that the most recent metrics are the ones you care about the most. So not only does it service storing the metrics, but it keeps those metrics in memory for a little while so that as you query them with the Graphite web, it doesn't have to read them from disk, which is kind of nice. Whisper is the flat storage file mechanism behind Carbon. So when Carbon writes, he can write to Series, Cyanite, or Whisper, and Whisper is the default. It's kind of like RRD. It's, you know, .WSP is like a .RRD. So how does this scale? Because that's always a big question. And the thing is, if it scales really well. Jason Dixon is writing this book, Monitoring with Graphite. I think almost all the chapters are done now. It's up on Safari, on O'Reilly. And you can, if you buy the pre-order, you can actually read it online. It's amazing. I can't do justice to this topic in the length of this talk. There's a whole chapter on scaling graphite in this book. It's amazing. Do stuff on SSDs because, I mean, there's that, and yeah, they do fail because there is a high read and write load on these boxes. When I was working for Booking, some of the guys at Booking wrote some components that drop into the Graphite infrastructure because, like I said, every piece of the infrastructure is pretty much, you can just like have a TCP relay that talks from 2003 to 2003, and then you can do whatever you want in the middle. So these are some tools I recommend checking out if you're especially interested in getting high read performance from Graphite. These things solve a lot of issues that you might run into if you have very high read loads, which means you're doing it right. So I get asked this now that like Influx is taking off like in the Twitterverse. Would I deploy Graphite today? Absolutely. Influx is still too new and still has a lot of, they're still learning a lot. So they have a lot of really good groundwork that they're putting down, but for production stuff that I rely on, I would use Graphite. So Graphite stores data in Whisper files. Every file is, every dotted notation that we just looked at is a file, is a directory or file on disk. So it looks like this, right? So if you have sys.datacenter.zone.host.metric, yeah, it's pretty simple. And that's how the searches work. They're just glob searches in Python. So it searches through the file system. So anything that you would use to search for a file on disk, you can use in Graphite to resolve a metric. As data ages, it becomes less important. And as it becomes less important, generally we just discard some of that data. So what the default is basically just to take an average of all those buckets and take like 5 of those buckets and put them into one with an average. As we do that though, we lose granularity. And this is an important concept to understand. You can change this because you can change aggregation methods. You can duplicate metrics and then change the aggregation methods that those duplicated metrics use, so you can preserve things like the average, the median, the min, the max, and or the last value. This is the storage schema, which defines the retention periods for your metrics. The default is 60 seconds for 14, well actually the default is 60 seconds for 1 day. So I like having that as a default because if somebody creates a new metric path in the Graphite infrastructure, they can't fill up all the disks on all of the Graphite servers, which has happened. Yeah, you know, like somebody gets a great idea that they want to count the number of requests from each IP address. There's only 255 in each bucket. That's really not that big. So yeah, we're not good at exponential math, and so I like having that so that it's a cutoff point. But this is actually what I run with now in production is basically 60 seconds for 14 days, and then 30 minutes for 2 years is the default. You might want to like have a different like TMP that has a smaller retention period, and you can have as many of these rollups as you'd like, and you can configure them however you'd like. Then there's the aggregators, and what the aggregators do is how are those boundaries handled? So the default is, this is the Graphite default, and if you haven't touched anything or you don't have a storageaggregation.conf, this is what happens, is you need to have at least 50% of the data in that bucket, in those series of buckets to perform the roll-up, and it uses the average to roll it up. So X-Files factor, it's not fear factor for aliens. It is a float between 0 and 1. And that is the number of non-null data points that must be present for an aggregation to not roll up to null. So how much you tolerate nulls in your data stream. Because if you have nulls in your data stream, then your average on one bucket may only contain 3 metrics, and the next bucket may contain 5 metrics. And now your average is not exactly what you expect it to be. You have to be conscious of this, and maybe your tolerance is higher for nulls, or maybe it's lower, and you want to have everything there before you perform a roll-up. The aggregator functions are average, min, max, sum, and last. So if you have a counter object that you're storing data on, you might want to use last as the aggregation method, because that makes more sense than average for a counter. If you have something that you're like an event that's occurring, you might want to use sum to count the number of events that have occurred in that time period. So when you get a 5-minute roll-up, you're counting all of the events that occurred in that 5-minute point. Does that make sense? And then min, max, and average, you can use, like, if you what I usually do is I'll have an entry in here that says dot star underscore min, and then I'll change the aggregation method to min for that bucket, or max, same thing. You might come across this on occasion, and there be dragons here. So this is, somebody got an interesting idea to store all the Nagios alerts on a minutely basis by host in Graphite, which is just wasting a ton of space. And because most of the time there's no data for a host in Nagios, the X-Files factor was set to 0, which meant always aggregate regardless of how many things are there, and aggregate on sum. This may not be the right place for that particular data if you see something like this. And again, remember, as you roll data up across retention boundaries, you lose granularity. It's pretty common sense, but you know, there's a 1-minute average, there's 1 minute, and we have a high of 80. After 5 minutes, that's dropped to 28, and then after 25 minutes, it's down to 9.6. So you will lose granularity as you go across retention boundaries. So how do I use it? How do I get data there? That's it. That's all you have to do. Wherever Graphite is, just send it the data notation, send it the value, and send it the epoch of when that event was generated. And if it doesn't exist, it's created. If it does exist, it's updated. It's really simple. Like, that beats the crap out of our RD tool. The important thing is, I don't even like telling people this, but epoch is optional, and if it's not specified, it will use the epoch when it gets to the storage engine, which may or may not be when the actual event was generated. So always send an epoch with your data, and if you can, enforce that in a relay. There's a lot of ways to get, a lot of libraries, like search CPAN for Graphite. There's like 6 or 7 modules. But you heard time series database, and you came here for pretty pictures. So here's an ugly picture. Oh, wow, that does not look good at all. I tried to use the Craigslist purple, but it didn't work out. So anyways, across the top in this composer window, which is the middle window here, you have a refresh button. If you click that button, it will refresh the data in the graph. The next one over is absolute time. So if you want to say between 2016, 6th of June at 10 p.m. and 8 p.m., you can use that to select an absolute time. The next button over is a relative time. So if you want to say last 24 hours, you can use that button to do it. The one with the bar and the arrow up, this is awesome sauce right here. So if somebody pastes a Graphite URL into a channel at work, you can copy that URL, click that button, paste that URL in there, and boom, you have that graph in the composer window, which means you can manipulate it. So one of the things that I like to do is go, hey, y min equals 0. Because people like to eschew correlation by not having a y min set to 0. Because Graphite will render this graph to fit the window. So it's going to try to constrain whatever metric you have to the size of the window. So the y-axis is going to be wherever it needs to be to make the prettiest graph, basically. Most of the time you need to set y-min equal to 0, and then all of a sudden your correlation disappears. The next one over is a short URL generator. So if you want to paste a URL into a channel, you can generate a short URL and get to it there, and it doesn't mess up in somebody's Jabber client or IRC client. On the left side, you have a metrics browser. I use that occasionally. There's also user graphs, but this is data exploration right here. This is really the power of Graphite. It's horribly ugly. And you don't realize how powerful this is until you start playing with it. This is the main reason why Graphite beats almost anything out there in the graphing space, is because from here, I can explore my data. And there's no constraints on what I can do. There's no presumptions about how I want to see the data. I can control everything about the graph and the data that I'm retrieving here. Yes, question? The question is, does it have facilities for correlating to time series databases? No, it'll only use what this Graphite web server is set up to use as data sources. Now, if you have a data source that can speak Graphite, you can set it up in the Graphite web configuration to also be a peer, and those metrics will be merged, and you'll be able to see all of the metrics in here. So if you have like multiple clusters of Graphite boxes, you can include those clusters in the configuration, and all of the data will be merged into the metrics that are displayed. This bothers the crap out of me. There's an autocomplete feature that's built in. You can't disable it, and it has a tendency to, like, if you hit enter right now, what you think would happen doesn't happen, and that's terrible. Hit escape and then enter. That's minor quirk. So let's take a look at why this is so awesome. So for instance, I just want to see the number of log entries that have been indexed, the total number and all the different nodes. So here I just put a star there where the node identifier would be, and I have all of the data on one graph. That's it. That's all I had to query. If I want to, I can select which log processors I want to actually include. So I can use, like I said, anything that you can use in the shell to generate a file name, you can use in a metric to expand. So here I'm using a character class to expand, so now I only have 2. I can use the curly braces, so I can be very specific and say just these guys here, use commas and curly braces, so now I have just these 2. Like, you see the metric names, you don't need to read them, but they're pretty long down there, and I like things to be pretty, so you can do things like change the way that they're displayed in the graph to say alias these by node, and then you give the 0-based index node in the dotted notation, and now your labels are pretty. Pretty labels are better than ugly labels. You can combine all your metrics together using sum series. Maybe you have 2 wildcards and you'd like to combine them. So here we're combining on the 3rd element, or 4th element, because it's 0-based. So we end up totaling all of the node identifiers and the class. So here we have all of the ones that resulted in errors, dropped, ignore, bad from all the hosts. So we can combine data like that. We can average the series, same thing. We can average series with wildcards. So we can do the same thing where we're looking at these total and ignore bits on average across the entire cluster of things. Oops, I pushed the wrong button. Or I have the slide twice. There we go. So you can do percentile of the data. This may not do what you're expecting it to do. So n percentile will generate the 95th percentile as a constant line for every data point in your selection. So here we have constant lines at the 95th percentile for the time range across. Now, what I probably wanted to see is the 95th percentile at each interval, and that's a different function called percentile of series. So now we have the 95th percentile at each time point that's being graphed. which can be helpful. We can select metrics. So maybe I want to see the ones with the highest standard deviation. So I can ask for the most deviant too. This is an instance where I'm like not super thrilled about Graphite, because this is kind of like the needle haystack issue in PHP, where you have to have the function reference available to know whether the 2 comes first or after the thing. But this function is really useful for finding really weird stuff in your data. You can select the highest current available, and here the 2 comes at the end, the highest 2 current. You can select the highest average, so this is across the graph, the highest 2 average here. And we can start transforming metrics. So generally when I start to see patterns like this, it usually means that I'm storing a counter. And that counter is going to increase, and it's never going to reset until the service is restarted or it hits an overflow point, right? So this is helpful to be able to see these types of things occur, but usually what humans are looking for is actually the derivative of this, the change at the time. So when I start to see these step patterns or these constant lines with a constant slope, then I start to look at the non-negative derivative function this is my y minimum. So yeah. If you look at the graph here, the top graph, you'll see an example of what I was talking about. The minimum there is not 0. It's not even close. And that's because it's just basically saying, I want to fit this graph in this point. So here's my x and my y that I need to fit the graph and make it pretty. So this is one of the most common transformations I do on a graph that someone pastes into an IRC channel is, y minimum equals 0. And then now, that looks a little bit different. It's the same graph, but with y minimum set to 0. So using non-negative derivative, we can then actually graph the change over time. There's also integral, so if you have a derivative, a change over time value, you can actually transform it back into the interval and see the slope of the line if you'd like. You can actually select data points. So here we're removing any data points that are above the 95th percentile. And this actually removes them from the graph, so they become null, but then they don't cause the graph to skew. But they are null. We can scale them per second. We can scale them per minute. We can scale them however we'd like to. I did find a bug with this that I'm still writing the bug report for, which is scale to seconds over a retention boundary does not calculate properly. But it's still useful to have, especially for current data. So here, this is one thing that I did a lot, was trying to figure out why Elasticsearch was broken. And most of the time, it had to do with garbage collection. So first, I start out with the garbage collection in milliseconds. And there's these spikes of lines. Now, really, the problem really only creeps up at certain points. It's usually when it's above 30 milliseconds. So if I wanted to, what I could do is I could push that line down to minus 30 seconds, right? So I basically offset it minus 30. And what happens in your mind is that you see 1. But then I draw as infinite. So anything that's above 0 gets drawn as an infinite value. And I see the second one, which was there in the first one, but our brain doesn't really catch it. So if you want to look at event, you can transform your time series data essentially into event data based on thresholds using features like this. We can compare metrics. Here we're comparing the amount of stuff that's been logged based on now against a time-shifted value 7 days back. So you can see the green line is going to be last week, and the blue line is today. So that's kind of neat. You can kind of see what's going on there. You can then take the difference. Here, I draw a constant red line at 0, and then the difference from now to last week. So I can see when I'm above and when I'm below last week's values, which is kind of neat. And we can do forecasting. This is Holt-Winters forecasting is built right into Graphite, so we can draw confidence bands directly on the graph. And places where the red line would break outside of those gray lines is actually would be considered an anomalous event. Something abnormal has happened here. And you can read the function reference. You can configure the Holt-Winters parameters as well in the graph. I usually tend to use the defaults when I'm using them, but you can change some of the parameters there. So what I found was a correlation, not causation, between the number of documents in the Elasticsearch cluster and the amount of time that was spent in garbage collection. So this graph kind of helped me understand like where the threshold was for the number of documents. This graph doesn't show it. I forgot to capture that, but there was a point at which when the green line went up too high, the heap memory used was very, very high. It has to do with how Elasticsearch stores references to documents in memory. So here, now we can find what I'm doing here is anytime the garbage collection is greater than 250 milliseconds in the cluster, that's if two of them happen near the same time, that can cause issues. So here we have each one of these lines represents each color represents a particular node in the cluster, and each time that cluster node hit 250 milliseconds or higher of garbage collection, we have a vertical line. Again, this isn't terribly useful as a graph per se, but if we overlay other statistics on top of this, we now have event data on the graph, and this is now an event system. So I can look at these events using code rather than graphs and find out what else is going on there. All right, so do I even dashboard? Like, these are graphs, but that's great. So I highly recommend Grafana. Grafana used to be, so the origin of the name comes from Kibana. Has anyone heard of Kibana, used Kibana? Yeah. It started out as kind of a toy. It was kind of cool. It made pretty graphs. Now it is evolving into a full functioning monitoring platform. Grafana now supports multiple time series database backends on the same graph. So if you want to, you can graph Elasticsearch, Graphite, OpenTSDB, Prometheus, Influx, and if your application supports a simple for-call API, your own application's metrics directly on the same graph. There's also some really cool features. I'm going to try to break out of the fourth wall here. Where's the, yeah, over here. So you have full control over the graph styling. You can create dashboards with any number of graphs on them. It supports Graphite, Elasticsearch are the two big ones, but it supports a lot of other data sources, and there's a plugin infrastructure which supports even more. Here's where we start getting into some craziness. Template variables. Grafana allows you to make an Elasticsearch query or a Graphite metric search, and then from the results of that search, generate a variable that you can then use in your graphs and dashboards. So in this example here, you can see that they've created a variable and selected as multis. They can tick these boxes and add or remove from that graph in real time, which is pretty amazing. I was actually working on a project to do exactly this because it's so useful. You can then say on a graph or a panel, for every one of these things that the user selects, repeat this row or panel. So you can have multiple hosts or multiple builds, multiple locations on the same dashboard. And if the user selects 3 locations, they can see all 3 at once. If they only select 1, they just see 1. It's very powerful and simply, it's amazing. The dashboard sharing feature is, why hasn't this existed? There's a remote sharing feature using the guys that developed this is raintank.io. I don't recommend using that because, again, you're storing your metrics in someone else's cloud. But there is a local snapshot feature available which stores it in your database backend. And what this does is whatever graph you're looking at, when you click Share and Snapshot Dashboard, everything that you see on the dashboard, all the metrics, all the values, all the graphs, all their parameters are snapshotted and stored in the database. And then you can go back and look at these snapshots. So if you have an outage event, you can snapshot the dashboard and document it, and it will exist for prosperity. You can set the expire period automatically, or you can set it, the default is never. And then you can always go back to that dashboard and look and see what's happening. For like postmortems, it is amazing. And it's also really helpful because then you know, regardless of who's looking at your dashboard, when they pull it up, they see exactly what you see. So there's no like weird, rendering issues or any of that stuff. Or maybe the data's been rolled up and now the data doesn't look right anymore. This stores the data as it is, all the data in the local snapshot. It is amazing. It allows you to authenticate. You can have multiple organizations, so each organization can have their own, think of it more as departments, have their own dashboards, create their own dashboards, share their own dashboards. And then there's annotations. And this was really cool. What I did with this, just as an example to demonstrate its power, was I used, we had error logging, exception logging going into Elasticsearch. I was able to create those as annotations on the graph and map that against page views. So you could see where an error occurred and where errors occurred and what effect that had on the graph, which is really cool. I don't know if they have really good visuals here because they're using the dark theme, but you can see these red lines here with these tick boxes down here. And the nice thing about this is if your document is in Elasticsearch, you can tell Grafana, use this field to display this annotation. This is the title field, and this is the description field of this annotation. So you can have your, when you click on this, you can actually see the event data from Elasticsearch that's associated with that event. It's amazing, like really, it's transformative. Also supports theming, so you can have a light theme if you'd like to. It's pluggable. Like I said, you can write your own. You can write your own panels, your own graphs. You can write your own data sources. So the world is your oyster. You can start incorporating your data into it. The time range selection is awesome, and there's a number of like apps and stuff. At grafana.net is an overview of all the plugins that are supported. So you can add a clock in if you'd like to, a world clock. It integrates with Zabbix, with Boson. There's a pie chart if you hate people and you want to make them hate you. It integrates with OpenNMS. I just saw this. Stage Monitor got added recently, which if you do a lot of Java, if you support a lot of Java frameworks and they use Stage Monitor as it's one of the JAMX monitoring plugins for Java, you can now natively pull data from a Stage Monitor box. The Percona actually supports like a performance gathering system. I think the backend is Prometheus, but they have an app that they've built, which is an overview. Oh, that's the nice thing. Is like you can take a whole series of dashboards and create them as an app, and then upload that or distribute that so that you can actually have like a representative sample of what monitoring your application looks like, and install it, reinstall it. And then again, here's the Elasticsearch plugin. Whoops, I hit stuff. And really the kind of cool one, where'd it go? Down here, simple JSON. This is awesome. So basically what you do is, no, you're not gonna support that. Oh, here we go. There's a few API calls that you have to support with the simple JSON plugin, but that'll instantly add you the ability to do templating and annotations and also pull time series data. So if you have your custom app or your Apache stats page that you'd like to integrate with it, you can do that instantly with Grafana. All right, now let me jump back over here if I can. There's also Graph Explorer. It doesn't have quite as many. Oh, the other thing is, on the feature pipeline for Grafana is alerting. So you can drag and say, this time period is what I want to alert on. If you see this happen again, send me an alert. which is pretty powerful. It also supports static thresholding. That's going to probably be in the 3.1 release, so it'll be like a one-stop monitoring thing. There's Graph Explorer, which is similar. It supports the metrics 2.0 like key value stuff. There's Cubism, which is kind of cool. What I'm going to be working on soon is a Cubism plugin for Grafana so that I can get Cubism graphs in Grafana because I need that. And that's pretty much all I have. Thank you. We have time for question. I'm just going to steal Sawyer's idea. Like I can do questions, bonus material, or both. Does anyone have a preference? Who wants bonus material? Just bonus material. Bonus material or just questions? I'm not as good at this as Sawyer is. How about both? All right, we'll try both. So bonus material real quick. How do I know how I'm doing in time series? Always compare the data to the same day of the week. Here is a graph of, this is actually very easy to do in Grafana. This is the past week. This is today all the way back to 7 days ago. And there's one line that fits really good, and the rest of them, they come close. Some of them come close, but they're not exact. Always compare to the same day. Anyone have any guesses as to what breaks this rule? Yep. National holidays generally tend to look like Sundays. So that's kind of the gist of this. Again, thank you. Questions?
Comment more, but if you're working like with an external vendor and you have a graph that's like this is where your stuff broke, that's when uploading to RainTank is actually pretty nifty because it's easier than like giving them access to your system or
True.
screenshot.
True. So the comment was that the uploading to RainTank is really useful when you're working with external vendors and you want to share, this is where your stuff broke, here's the graph that I'm looking at, because then you can share that link. It's public and it's automatic. Yes, that's correct. Yes?
So I saw you were looking at Elasticsearch. How often do you integrate like your apps? Does your app feed into Graphite at all?
My app?
Yeah, like whatever custom code you have running, do you ever feed data from that into Graphite rather than looking at things like Elasticsearch
Okay,
or
yeah.
hardware stats?
Okay. So the question was, do I feed any other data other than just pulling data from things like Elasticsearch and system metrics into Graphite? And the answer is absolutely. Anytime that I can. You may be familiar with Etsy. They did a lot of this work. They have a program called StatsD. There's a number of like C-based StatsD daemons, so you don't have to worry about Node that supports StatsD. I highly recommend checking out StatsD. StatSite is what I'm using for my StatsD implementation. It's all written in C and packages nicely on Linux and FreeBSD. Etsy's philosophy, which I highly agree with, is if it moves, graph it. If it doesn't move, graph it anyways, because if it moves, then you're screwed. So if you're doing anything, if you're writing a subroutine and it's public-facing, your users are going to hit it, why aren't you timing it? With StatsD, you can sample. So you can say, I only want to sample this once every 100 times, but please just tell me how long it takes. It's insanely useful when you hit debugging and you want to know, where's my app dying? Well, yeah, sure, you can do flame graphs in NYT-Prof, but if you have a corpus of data of real life and you can see how that evolved over time, you can pinpoint something changed here, what changed here, and it takes troubleshooting to a whole new level. StatsD, yeah, and StatSite is a really great implementation of StatsD in C. And like I said, then you don't have to worry about all the Node.js packaging stuff, which is not usually easy to do on things like CentOS. Any other questions? Yes, over here.
Yeah, is it a challenge to find a balance in the aggregates you use when you're recording, so that when you're recording, you can get the information out that you want?
Okay, so the question is it a challenge to find the balance when you're using aggregates to get the right data out of the system? And I would say there's a lot of like blog posts on this about where people ran into issues, And I know we all think that we're snowflakes, but we all do the same stuff, and we all have the same problems, and someone has already run into that issue before. So generally, like, Google what you're collecting, and you'll usually find like an aggregate philosophy. And like, for instance, like with StatsD, the names of the metrics are consistent. So when it writes a sum, it has _sum in the name. If it writes a min, these things are consistent. And so you can actually just go, and I did because I was like, I can't think of every single permutation off the top of my head. Someone has already got a gist up on GitHub that says, here's how you would do StatsD aggregators. And usually the defaults are okay. So you have to be cognizant of the rollups. This is like a intuition. It's not going to, you don't use this to bill people with, right? So keep that in mind. And that is all the time we have. Come talk to me. I can talk about this for days on end if you have any other questions.